Today we're going to talk about right triangle trigonometry. So this is something you did learn in geometry. We're going to refresh your memory with it today. So obviously for this we need a right triangle here. And I'm going to say that this is triangle A, B, C. Now will it always be A, B, and C? Absolutely not. Those are our angles. And then the sides are across from the angle. So angle A is across from side A, angle B is across from side B, and angle C is across from side C. Okay, so we have a right triangle. You also learned SOHCAHTOA was a way to remember our right triangle trick. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So keep those things in mind. With that as well, you need to know opposite, adjacent, and hypotenuse. And so that's going to depend on what angle you're focused on. So let's look here. If we're focused on angle C, let's just say for this question. For any triangle, for any right triangle, whatever angle you're looking at, the hypotenuse is always going to be the side across from the right angle. Okay, every single time, doesn't matter. If we're focused on angle C here, then the opposite is going to be across from that. So our opposite would be over here, and then our adjacent is going to be the one right next to this. So this would be adjacent. And I don't want you to confuse this angle A with this A here standing for adjacent, okay? And then obviously if you were focused up here on angle A, the hypotenuse is still here, but the adjacent would now be here, and the opposite from angle A would be over here. So you just need to be very careful of what you're dealing with, okay? So the first example that we have here is this. We have a right triangle, and we know that this side here is 7 meters. This angle is 55 degrees, and we are trying to find this side there. So if it helps you to put letters with things, great. You don't have to put letters around the sides of this triangle, but since we're focused here on this 55 degrees, we know that here's the hypotenuse. This 7 is across from it, so that's the opposite. Since we have opposite and hypotenuse, that means we're going to be using the sine. So the sine of 55 degrees is going to equal opposite over hypotenuse. And then we have to solve this equation. So this is technically just a proportion, so I can cross multiply. So we would have x sine of 55 degrees equals 7. And then to get x by itself, we would divide both sides by the sine of 55. So here, we're going to do 7 divided by the sine of 55. And we don't know what that is, and I don't expect you to know what that is off the top of your head. So we are going to use a calculator. Now, with this, you do need to make sure that your calculator is in the correct mode. We are dealing strictly in degrees. So if you click mode, and then if you go down here over to degree, click enter, that will turn it into degree mode. Your calculator should always be in degree mode unless you change it out of degree mode. But every single time you're starting these questions, I would make sure you're in the correct mode, because if you're in radian mode, you're going to get every single question wrong. All right, so now we can exit out of that, and we're going to do 7 divided by the sine of 55. And all of our answers, like we've been doing all year long, we're going to round to the nearest thousand. So that means we need 3 decimal places. So this would be 8.545, and then our unit is meters. So then that would be our answer for that side length. And one thing you can do to kind of double check, the largest angle, which should be your right angle, should have the largest side across from it. So 8.545 is bigger than 7. So that makes sense that 90 would have a longer side length across from it than 55 degrees. Okay, so that's one way you can kind of check your work as you're going as well. All right, so let's try this one here. So we have another right triangle. Again, it doesn't matter the orientation of that triangle, as long as it's all here, you're good to go. So we have, this is our angle, we have the opposite and the adjacent, which means we're going to be dealing with tangent. So if it helps you to put in the O and the A there, great. If not, that's also okay. So the tangent of our angle, 32 degrees, is equal to opposite over adjacent. So in order to get x by itself, we're going to multiply by 14 on both sides. So that means that x would equal 14 times the tangent of 32 degrees. So we're going to do that math here in our calculator. And we get 8.748 inches. You got to make sure if there is a unit that you're putting that unit with your answer. So if we're looking here, you know, this is 32 and we get 8 there. This is 90, which is going to be something much greater than that. You could, if you wanted to, take those, subtract it from 180 to get this angle to figure out which one, you know, should have the longest or the shortest. But this one should be the shortest because it is the smallest angle with all of these. All right, and eventually you'll see questions that ask you to solve the triangle. That means that you are going to have to find all the angles and all the sides in each of the questions, okay? All right, so the last one then is where we have to find the angle. So we've done all the other kinds so far, where we'll go back and review those things here shortly. So now we're trying to find what the angle is. So we're focused on this angle here, and we have the adjacent and the hypotenuse. So we're going to use the cosine. Okay, so the cosine of x is going to equal adjacent over hypotenuse, so 9 over 21. Now, how the heck do we get that angle x? That's where we say angle x is equal to the cosine inverse of that fraction 9 over 21. And you could simplify that fraction if you want. You don't have to, you know, in this process. So in order to get that cosine inverse, you do need to hit second and then cosine 9 divided by 21. And then still, we're going to round this to 3 decimal places. So 64.623, and our unit here is degrees because we're dealing with an angle. Okay, so let's refresh here really quick. We did one with sine, one with cosine, one with tangent. Those are your 3 different operations or 3 different functions. Here, when x was in the denominator of this, these two switch places, okay, because it is a proportion, things on the cross can change places. So when x is in the bottom, you're going to divide. When x is in the numerator, in the top, you're going to multiply. Okay, you're going to multiply that piece. And then when you're trying to find the angle itself, you are going to do the inverse.